So good morning. We are going to study today, means we are going to learn today optical experiment. Okay, optical experiment. Okay. So what is optical experiment? So let's start. So at first there is a light emitting source. Okay, there is a light emitting source. For it I have taken okay, it produces light. So light gets emitted from its light source. So from here, the light, if you observe clearly, it is an electromagnetic wave. Okay, and it is means multidirectional. It's multidirectional. So it is passed through a membrane or through a system. Here it is called nickel, or it can even be calcium carbonate also. From this we obtain a unidirectional light source. Okay, it is easy for us to observe and to study on. Okay, so it is passed through a solvent, or now this is also called as plane polarized light, PPL, plane polarized light. It is passed through a solvent. Okay, the solvent is placed in it, and it is also known as polarimeter. Okay, you can mark it as polarimeter. Okay, so now the observation that we get is, get two types of PPL. It's not two types, but observation of PPL is as dark zone and bright zone. Okay, so now the bright zone that we observe, the bright zone that we observe is inactive, optically inactive. So it interacts with light. Okay, interacts. It interacts with light. Interacts. Okay, it interacts. But we don't see that much. We don't see any change over here. Now you may think, now this is the light. Okay, light source. Now, oh, okay, this is the light. If I draw PPL, so now it interacts with light and turns it or rotates it. Now tell me, when can we not see any change? I hope that you may have guessed it. When it is rotated 0 degree or plus minus n pi degree. Write it again. At plus minus n pi degree. Okay, one is this. Now why one n pi degree? Okay, I don't have any means to explain, but I'll try my best to explain. Okay, just a second. Now if I rotate this 180 degree, so not 180, if I rotate it 360 degree, okay, n pi, okay, remember, okay. So if I rotate at 360 degree, this is, say I put a point here, it will rotate and the point will come again. So I'll not see any change only, na. It will be at the same position again. Or again, if I do um 360 into twice. If I do 720 degree, if I do, it will go like this once, again twice. Okay, we'll observe that. Okay, so that's why. Okay, now coming back, now coming to the dark zone part. They are called optically inactive. Okay, important. If I come to the dark zone, now the real game begins. Can do a whole bunch of calculation based upon these things. Okay, there's a whole bunch of calculation going around these things. Is further you will also learn how to calculate the a different type of angles you will be able to calculate the specific angle of rotation and etc. etc. First, you have to understand the basic fundamentals. Okay, now dark zone or optically active compounds. Okay, these are optically active compounds. Optically active compound. Okay, anti-clockwise and clockwise direction. Okay, we put it as minus theta plus theta. Okay, sorry, just a second. Made a mistake here. Theta. No. There's a big mistake going on here. Okay, if it is located 2 degree clockwise, you can see a bit change in it. You can imagine it in your mind also. It's a bit tilted and all. Okay, this is called lextotatory. Difficult name to pronounce. Just you have to delete it. Check the spelling. It's L. We have initials are L and dex rotatory. Dex rotatory. D. Okay, this is what we call, and mostly our whole calculation is upon these things only. So, so thank you. I hope you understand.